All right.
Okay, so before we start, let me introduce our last keynote speaker for today. This is actually, originally, if you noticed our program, we were supposed to have Izik Kirshenbaum give the final keynote talk, and he couldn't make it in the last moment, but he found a very worthy replacement. And Aviv, in fact, is the VP of Mobile Wireless in Intel, and that's a fairly high position, and he was the one who's responsible for many of the funds that the Advanced Communication Center received over the years, and so we owe him special thanks here. So he will give a talk about what it means to be a communications engineer, I suppose.
Oh, yeah.
Observe the communication edge.
Yeah, so a few more words. That is true. I mean, Izik called me on Friday and asked me to replace him. And since I'm basically leaving Intel at the end of this month, and I'm kind of in a middle life retirement, I said, no problems. I'll come over and see what it takes to do it. So I'm happy to be here actually, and I hope you will be enjoying this one too. So the presentation was made by Izik. 90% of it, I just added a few things from my perspective. Izik is a well-known guy in the industry. He used to run one of the elite groups in the army. He was the co-founder and CEO of Envara. This is where we met. And then Envar was acquired by Intel. He started as the GM, general manager of WiMAX in Intel. In 2006 he left, was on advisory boards of several companies, and then founded Siklu, which is a very interesting startup, and the target of this startup is to basically unclog the bottleneck of networks in the back end. This is something that today people are not really aware of, but it's one of the biggest problems that we're going to see in the next few years. Okay, so that's Izik, myself, many years in radar and wireless communication. I was system engineering and managing big projects in the Army, from acoustic to KA. I used to be the VP R&D of Envara, also acquired by Intel, of course, as before. I took over when Izik left, and I was the director of WiMAX, basically running the group, and then was asked to be the manager of the wireless division of Intel. It's a pretty big group. It's 1,100 people, close to $500 million revenues, and something like 40 million chips a year. All wireless devices of Intel actually went out of this group, and surprisingly to probably most of the people here in the group, all of the R&D of this group is being done in Israel. Okay, so actually the wireless division of Intel is the largest wireless company in Israel that nobody knows of. Okay, so I'm done for that one in January, and moving on to other things. So basically, if you look at the wireless communication arena in Israel, we see many wireless companies. Most of the ones above are startups that became companies, startups that died as startups or just are still there. A lot of wireless system houses. You see also a lot of silicon companies. Some of them are the same. Some of them do silicon and system. And you see global presence of silicon system companies like Intel, TI, Marvell, Nokia, Siemens, Motorola, and Hotel. I actually sad to say that that side is shrinking. Okay, so if you see what happened in the last few years in the Israeli industry, there are less communication companies coming to Israel, and we'll talk about the reason for that in a few minutes. So basically we got a wide talent base. We can see that we have everything almost. The community is very small, it's very connected. So CEOs from different companies talking to other CEOs, talents are moving from one place to another, and also information flows from one place to another. Okay, so for example, can I use your name? So when Amimon wanted to know a few things about the markets and where to go, we had a very nice conversation. They got the view of Intel and in general what we can see, and vice versa. We understood what are they doing, and try to see if it's relevant for us, and that's I think a very good thing. And also there's a product orientation which is growing. People think more about products and not only about technology. So that's a very good place to be in if you want to do something in communication. Now what makes it the way it is? First and foremost, I think it's the defense industry. There's a lot of talents coming from there. A lot of system knowledge is coming from there, or used to come from there. And I think when you look at the situation today, this is going to be a bit of a problem because approximately 15 years ago, a lot of money was shifted from shekels to dollars, and that caused a lot of projects to basically be purchased outside, and the self-innovation and basically self-development shrinked. It moved from doing it inside actually to going and buying something that is on the shelf. And of course, you lose a lot of knowledge. And we see today the knowledge that people come with from the army is shrinking, and that's not good. Important talent, immigration, a lot of people from all over the world, if it's Russia or the US, France, a lot of people bringing information and technology, and that's extremely important. We've got entrepreneurship culture. People don't really look only about their salary, and running a team that covers from Malaysia to the US, I can tell you that the Israeli culture is different. Okay, and this is something that is very good because if you want to invent something, you need to know that your life is going to be miserable and you're not going to get paid a lot for a long time. So this is something that we have, and that's good. Israeli culture, these are the good things. I'll touch the bad things about it. We're open, direct, we're daring. It's typical for an Israeli guy to come and to approach someone and ask the direct questions, and come out of nowhere, pick up the phone and say, hey, I need your help. Okay, it's not typical in other places. I'll touch again the bad sides of it. So if we look at the bottom line of this slide, we have a very good ability in Israel to start things, okay? To make it fast, to make it small, cheap, a lot of system know-how. We talk a lot. I think that right now the biggest problem that we have is the scaling part, okay? So if you're really going to look around you, you see that most of the startups don't get to be giants, okay? And if you look at manufacturing, for example, and I'm going to touch that in a few slides, you'll find out that most of the startups are either being acquired or shut down, or being acquired and the knowledge is being taken out. And I can tell you that a lot of VCs, okay, are also looking at that as a problem. And this is something that we as industry need to go and change and get that into our DNA too. So what, from kind of 50,000 feet, what do we have in Israel that is kind of our strength and core competence? So we have deep communication algorithm knowledge. Okay, we have very strong 5 people. okay, and strong compared to any other place in the world. Actually, a few of them are sitting here, and I think this is something that we have today. System engineering, antenna to software, again, due to the Army, this is something that most engineers, if you see how people grow in companies, they grow slow, okay? It means that they get something, this little block, and then, another little block, and until they get to the point where they see the system, it's pretty late. What we see in Israel, it's a bit different. People that are coming from the Army or even other companies, they get big projects, big systems in their hands, sometimes old, sometimes new, and they have the ability to have the overlook not only at the system point but also system over time. And this is something that is important. People tend to forget about it. We have strong silicon architecture and front-end knowledge. We know how to move fast, integrate core IPs. We got the NIH problem as everywhere else, but we know how to cut corners. Okay, so if it doesn't work, we'll just go and buy it. We know about coexistence. Again, this is part of the system and understanding, and we also have a good knowledge base in the industry and outside, and in the Army and other places on location and tracking, which if you look in the future of this industry, especially the communication industry, a lot of location and tracking is going into it, not only from the PHY perspective, but also from the network perspective and also from the application perspective. And this is something that is extremely important. It's just in the beginning, and there's a lot of work that needs to be done over there to optimize and make things work better. So again, from high level, from at least both Izik's and mine experience, it was much easier to take system engineers, okay, and take them down to the silicon or down to the driver than actually take the silicon guys and make them think from a system perspective. I will give an example for that soon. But what are the gaps? It's very nice to talk about the good sides. Let's hear a bit about the things that are less, nice. So if you look at what we have the algorithm, we have the PHY. What we don't really have in Israel is protocol stack knowledge. Okay, there's not many companies that really have deep knowledge of protocol stacks. If you look, for example, on 3G, very small number of companies actually wrote a protocol stack. Okay, so there are a few companies that did it on Wi-Fi, one company or two companies that did it on WiMAX, but not much, and that's a very problematic thing. And the reason for that is when you don't have the control of the stack, for example, on coexistence issues, okay, or optimization issues, you're missing a lot. You don't know how and where to optimize really. This is something that is problematic in a kind of high layers. If you look at the silicon side, low backend skills, very low analog and RF silicon skills. Okay, and this is something that Izik started to push a long time ago. I followed him, and as an example, when we started, when I got the job of leading the mobile wireless group, one of the main things I saw when we basically contributed money to this program. Dov Andelman is there, and Dov, you can raise your hand. You're the guy that now that I'm gone, they need to know where to get the money from. So I think we started, and when I looked at it, it was like all over. Okay, and when we knew, we really knew what our gaps were. We had a huge gap in RFIC, okay, in Israel. And if you look today, the number of RFIC people in Israel is something like 70, okay, in Intel, okay, and maybe 70 in all the other companies, okay. And if you compare it to the US or you compare it to other places in the world, our situation is very bad. If you look at articles that are going out, articles are coming from people from Iran and people from Egypt, okay? And all of them are good people, but this knowledge sometimes goes to the places that us as country, okay, I'm not sure we want it there. So if you take it one step further, places like IAI, that used to be, kind of the house of radars for the world, small radars, everything is nice, is slowly becoming, or actually lagging other places in the world just because their systems are way more heavy, okay, ask for more power, etc. So when I saw that plan, I asked Dov and Meir and I said, look, this is the big gap, okay, and I ask you to try and put most of the money on that. And I think through that and a lot of thanks to what Meir did, we have today a lecture here in Tel Aviv that was actually brought from the US, right?
Yes.
And we started the seed of RFIC in Israel, and this is something that is extremely important. It's a classical kind of way of work between industry and the academy, okay, to close a gap that a country has, and this is a big gap. So this is the RF story, just as an example, but it's very small, it's just the beginning. Another thing that we're lacking is manufacturing knowledge. Most of the engineers looking at manufacturing is, someone will solve it later, okay. This is becoming a very critical thing in the industry, because today the money doesn't come from 5 systems. Okay, when you really want to make money, you need to start selling a lot, because the level of investment for projects is becoming huge. And if you don't sell it, by the millions, that becomes a problem. When you do that, manufacturing becomes a big key item. A big key item, and if you look from a company's perspective, a lot of money is being put in manufacturing. Sometimes you find out that out of $250 million of investment a year for a division, you can find out that $60 million goes on manufacturing issues. Okay, and for example, if you need to calibrate fast and you need fast algorithms for scanning and all of that stuff, you'll find out that this is becoming a key thing. We have nothing there. We don't know how to do these things, or we know but not much. Low networking knowledge, or more network knowledge. The number of base station manufacturers in Israel is small. Not many companies are doing that. Not many companies even sell a lot over there. The biggest one is Alvarion, and Alvarion is basically a midget in this world. And if you look at what we have in Israel, it always gets to a certain layer, and from that layer up, we just don't know anything. We use the help of Cisco, Ericsson, and others. And this is, again, when you look at optimization and what the world is looking for in the next few years, how it will take the traffic from one place to another. And there are amazing demographic models, okay, about these problems. Okay, you'll find out that this is a critical subject that we need to develop knowledge there. And the last thing, we are too proud of ourselves. We talked about the Israeli culture. We have the tendency to think that we know it all, we've done it, and we can do everything. And this is something that is sometimes problematic, not because it hurts you on the daily kind of life, but it blocks your ears. Meaning, when you go and meet other people from other places with other concepts and ideas, you stop listening and try to tell them what you think, and this is something that is not really helping when you want to grow and learn more. Okay, if your target is to conquer another country, that's a different thing, but if you want to learn and cross-pollinate with someone, listening is a good thing to learn. So we got the knowledge. We need to focus. All of that is somewhere around us, in Israel, outside of Israel. But we need to collaborate, and we need the openness to make it bigger and to grow it. And basically, this is, I hope, one of the things that ACC will get us to someday. How much time I have? I can talk for hours, so just give me the...
20, 25 minutes.
All right. Okay, so if you look at the global trends in the last 10 to 15 years, first and foremost, silicon size, Moore's law, everybody knows about that. Just a few years ago, we talked about 0.35 micron. Today, we've got projects running on 45 nanometers. We shipped our first 45 nanometer not long ago in Intel, and Qualcomm is doing that too. People already talk about 32 nanometer, 22 nanometer, and the 15 nanometer is there also. Okay, so it's by definition going to be smaller. Cost. This is something that usually people that come either from the academy or from the army don't really think about. Okay, but after 1 year in the industry, you understand that this is what it's all about. It's amazing to see how, you know, in 2000, people thought that $5 Bluetooth would be something, you know, if we're going to reach that, that's going to be, you know, fantastic, right? Today, if you look at the wireless LAN device, which is way more complex than the Bluetooth device, I can tell you that $5 is not that cheap. Okay, so this is something that we also missing, but cost is something that drives a lot of things in this industry. And the scale of the complexity of the device, and all of that comes together at the end. It used to be, you know, 3, 4 chips. That's fine. You know, then it's 2. Today, if it's not a single chip, it's not really interesting because it needs to go to your iPod or to your iTouch or whatever you find that you like, and then it cannot grow back. Okay, so you cannot come and say, hey, you know, there's a few more features, but this is the size that you need to put in your pocket. Consumers are, you know, very quick to throw things that they don't like. Okay, and then, you know, 4 years of development and, you know, multi-million-dollar effort is basically going down the drain. It's not so good if you're managing these kind of divisions. So I think if you look at the trends, it will get you to a very simple conclusion. It's about SoC. It's about system on a chip. Okay, and it's about having one single chip, having multicom on that chip. It means at the end of the day that you need to get very good system knowledge, okay, and very good silicon knowledge, merge it all together. Okay, so if you only have system knowledge, that's not good enough. If you only have silicon knowledge, that's not good enough. And since, as you've seen before, in Israel we got very good system knowledge, we have gaps in the silicon knowledge, and right now it's still not hurting us, but in the next few years it might hurt us. So definitely needs to close that. More things. The pace. If you look at the pace, everybody comes and say product cycles become shorter and shorter. That's not really true. If you really look at the product cycle, I don't know why, but if you do a derivative product, it will take you 2 years. If it's going to be something totally new in architecture, it will take you 4 years. I call it the I have no clue law. Okay, I mean, I don't know why, but this is what it is. And so the pace is there, it's the same pace. The thing is that the complexity becomes humongous. Okay, if you know, a while ago it was about, you know, Bluetooth or Wi-Fi in that chip. Today it's Wi-Fi, WiMAX, GPS, and another CPU there. And if you have another one, then just put it in. And that means that a lot of engineers from many places need to sit in on the same die. It's a mega change in the way you think when you go and engineer. and it gets you quickly to the understanding that you cannot do everything by yourself. Okay, and this is something that it's here, and it's in the U.S. and it's India. And to tell you the truth, it's pretty nice. It's beautiful to see it. Okay, and that globalization, which is the next thing that's happening, you find out that you cannot find it in one place. But the scary thing is that there are places, okay, that can have it all, okay, and in masses. So if you see what happened in communication, it used to be, very nicely in the Western world. I would say 8 years ago, if you try to find RFIC in Taiwan or a real good software in Taiwan, you wouldn't have found it. Okay, nowhere. Okay. By the way, the only RFIC guys or RF guys in Taiwan were people that Israel trained 20 years before that. Okay, and that was pretty nice to know. But 8 years later, these guys are doing everything inside. Okay, so there's RFIC in Taiwan, a very good one. There's software in Taiwan, and you see companies like Ralink pretty much hitting every aspect of the communication world. Okay, and I'm not talking about MediaTek. That today. MediaTek is a Taiwanese company. How many of you heard about MediaTek? Okay, good. Not good for you. But MediaTek, for example, is a company that sells super low-cost wireless chips. Amazing company. Okay, scaring Qualcomm. Who heard about Qualcomm? Okay. So Qualcomm is extremely scared from MediaTek. They sell in China, and now they're starting to sell also to the Western world. Okay, they do it very cheap. They do it very, very good. So here's an example of how things shifts in this world. And if we talk about the MediaTeks of the world, we can talk about China, India, and Malaysia. Remember, I told you that Notel, Motorola, they're not really there anymore. How many of the people here heard about Notel? Okay. How many people here heard about Huawei? Good. How many heard about ZTE? 1, 2. Okay. So just kind of to explain to you who is Huawei and who is ZTE. Huawei is actually the one that sells the most in the world wireless devices today. And ZTE is just right after Huawei. When you go to Huawei, it's a very interesting experience. By the way, it's the same thing with ZTE. You stand in front of big gates, and behind those big gates, there's a city of 400,000 people, okay, in a company called Huawei, okay? And this company, for example, and this is why you don't see Notel or Motorola or Alcatel-Lucent anymore, is because 2 years ago the Chinese government gave them $10 billion, okay, and told them, look, so far you did fine in the market in China. Now we want you to get the market out of China, okay? So they basically went and erased, okay, all those companies. The only one that really survived is Ericsson, okay? By the way, Elvarion, every time they hear that Huawei is competing on that same account, they just, they just go. Okay, there's no chance anyway. So most of the people don't really understand that massiveness. Okay, 400,000 people in a company. Intel is 80,000. Okay, so this is something that we really need to be worried about, and really need to understand that the edge, the technology edge, is always kind of for us to kind of run and get, and it's not you got it, now you can stay over there and wait because others won't come. These guys are running, they're running fast, and there's not even a single arena that they're not playing in. Okay, so by the way, if you can't beat them, maybe start joining them, right? India also, and Malaysia. I bet that most of you don't even know that there's a lot of engineering in Malaysia, but there are thousands and thousands of engineers in Malaysia, very talented engineers, very aggressive, and probably the next one in line. And the last but not least, conglomeration of technologies, many in one. Everything is going in that little iPhone. Everything, okay? From sensing your motions, from looking at you through your camera, and to communication, CPUs, and that means that you need to understand it all and not just a little part of it. So if we want to lead, we need to master those aspects and come with a competitive solution, which means time to market first, and then performance and cost. So what we've learned, is basically Izik and myself in the last few years. It was a very interesting journey, I must say. These are the things that we need to lead, but of course, this is not easy to achieve. I mean, it all sounds very nice on that slide. High performance, low cost, low power, and ready for mass production. This is something that we always forget. You get to the end, and then suddenly you find out that you need to manufacture 1 million units and not 1,000, and it's a bit different. We had that session in my office, right? And then cost, power, and size requirements. There's a big debate. Do you go to most advanced processes? The answer for that, amazingly, is no. Okay, there's a company called Ateros, and they were fierce competitors of ours in Intel and other companies. You can see that these guys can squeeze from point 13. Okay, amazing things. They can squeeze out the power they need, the size they need, and the cost is way better. So they, as an example, mastered, okay, silicon capabilities and system capabilities. Okay, and it was amazing to see this group coming from a place where they didn't know anything about system. Okay, they learned, they brought in system talents, but they also mastered the silicon, and they did wonders. So you really need to look at the system and understand if this is the right reason to go to very advanced nodes, very advanced processes, or just stay behind and tweak your system better and get good results. So this is something that definitely, if you don't have the knowledge, you don't know, and you automatically go to the more expensive way. And the rest, I think we touched. The last thing, and I hope that the previous slide try to expand it. Cross-pollination, not only with yourselves. Okay, we usually tend to kind of go to the guy next to us and talk to that guy or that lady and share the knowledge. The world is very big today, and the knowledge is spread all over. Okay, and if we want to open ourselves to the outside world, we're going to have a big problem. And I can tell you that we tend, and I'm saying we as kind of an average of many engineers that I've seen, we tend not to do that. Okay, and it's a basic fear that people have to open up, and this is something that can kill the industry instead of kind of grow it. And we have a lot to give. Others have a lot to give also, and you always find the people that really want to share and become bigger together than just try to steal your information. So don't worry about that. Okay, so that's the key question, right? So I'll start kind of with a high level thing. There's always a question: should the academy go and optimize yet another notch in the problems that the industry has, or should the academy look forward 20 years and do research, what we call the cloud research, right? It's kind of someone's looking way up there and has nothing to do with things that people are doing in the industry? Obviously, the answer is somewhere in between, or kind of both. I think that there are places that if you feel that the industry is in good shape, and I'm talking about the Israeli industry, of course, is in good shape, go far and try to look for the next thing that is coming. Okay, and this is something that is important. I think that in places where you find that there are mega gaps, RFIC was an example, and I gave a few other examples over there. This is not the time to talk about the clouds, because at the end of the day, this cross-pollination between the industry and the academy is critical, and if one side is gone, okay, then the other side will fall quickly after it. So on that perspective, there are gaps. I think the academy and the industry need to really work closely and tightly together to close them. And then, of course, that will go back to the academy if it's money, if it's facilities that the industry has and the academy really usually struggles to get. That will come back to the academy one way or the other. Specifically, I think if we go narrow it down to the things that we really feel that we have a gap, is the RFIC arena. I think that on that side, we really need to work together. There's huge amount of knowledge in the industry today. One of the things that we were lucky enough in Intel to have is to have groups all over the world, okay? And there's a lot of information coming and going, and I think the industry can really get a lot out of it if it's common projects, if it's lectures coming from the industry to the academy, and then vice versa. Practical work in these arenas is critical. Another key thing that we are missing is basically looking not only on communication per se, but things that are related to communication and starting to be important for the communication and then for the system. Okay, and we're talking about the sensors, the imaging. If you look at the automotive industry, this industry is going to go through a dramatic change in the next few years, and I think some of you are starting to see it. All of these things are tightly coupled, and all of them at the end of the day are going through communication. Okay, and this is something that people don't understand, that communication is one of the key sensors at the end of the day for any application, because that's what gets you the bits to the person, and that will give you the information of what is he doing, where does he want to go, and then how can you squeeze a few more dollars from him. Okay, so from the industry perspective, this is something that is important, and all that multi-sensing is critical for those applications. And the last thing is the network level. A lot of the work today is done like we did cellular 10 years ago. People still didn't encompass the change of data over networks, simply because the real data networks are just coming out. If it's WiMAX or LTE, it doesn't really matter. But people still think cellular, people still think voice. Okay? And I think if the academy will bring a lot of innovation through that understanding, and through the fact that in the academy there's the ability to unleash yourself and look really forward and bring new concepts, I think that will help basically unclogging some bottlenecks that we have. People think about the device a lot. They don't think about what the network can do for the device. Okay, when the network has a lot of knowledge on that person, okay, where is he going to go? What applications is he going to like? That can make the system work in a much faster way. It can save power. Okay, and things that you try to solve in the device space, okay, in a very tough manner. It's very hard to squeeze another milliwatt over there. You can suddenly understand that if you look at it from the network space, things become much easier. to do. And this is something that I think that is not there. People are not really thinking about it right now, and this is where I think we should try to excel. And one last thing, I can tell you that from the industry perspective, as Intel, we work with Tel Aviv University, we worked with the Technion, and just like, by the way, when we work with other companies, they tell us that Intel is a very confused company. Because, there's places that talk to you in kind of sign language, and then there are others that talk to you in Chinese. So this is what we see when we look at the academy in Israel. We see it a bit fragmented. It looks like there's not real communication between the different places and departments, and I think this is something that is important, okay, for the academy in Israel to do, because, as I said, part of the Huawei 400,000 people, okay, there are dormitories, canyons, and a university, okay. So Huawei has a university, ZTE has a university, and actually every other big company in China has a university, okay. We don't have so many universities, okay, and I think that the fact that we are not working together well between the university, I'm not saying that does not work, right, but I'm saying we think it probably can be a bit better. I think that will be a nice boost to what we can do with the resources that we have. Government support, definitely, and this is something that the industry and the academy can work together to push the government, even to take some budget from the chief scientist and move it to other needed places. And of course, industry support through students and projects and guidance. Okay, so at the end of the day, we need to make sure that we keep leadership. We're leading in many areas. I don't know how many of you know, but in the WiMAX, for example, standard, most of the leading companies were Israeli and Koreans. So that's good, but it's not like that in the LTE, and it's not like that in the next generation of the WiMAX standard, and that's not good. So we need to make sure that we keep that leadership, and that means that basically joining forces and working together in a much better way. Thank you very much. If you have questions, please do.
I have a question regarding an aspect that you didn't touch upon, that is student training, and within that, the issue of student work during their studies. In the United States, companies like Intel give them summers at Intel. Here, all the companies, Intel included, want them to work during the school year, 20 hours a week. What's your honest take now that you're leaving Intel?
So, there's always, there's several ways to look at it, and I'll give you another aspect that I'm pretty sure you didn't think about. At the end of every year, okay, we sit and, look at labor cost, okay. One of the key advantages of Israel is that we don't do those 2 months periods and then that's it. Actually, you find out that that students are amazingly talented. They learn a lot through the fact that they're working with the engineers, not coming for 2 months and going, okay. And the industry gains a lot from it because the labor cost of a student is lower than a fully functioning engineer. So I think, and I had both. I had the students in the US and I have them in Israel. I can tell you that the students in the US wish they could do what the Israeli students are doing. Okay, so on that side, I think we're doing fine. I think it's the right way. I think it's also a big win-win for both sides, both for the students and for the companies and for the universities.
Check the impact of debt. Because I, for example, asked students toward the end of the semester who opened the textbook. I must say they're at least honest.
I must say that I didn't work in a company, and I didn't open the test book too.
You're honest as well.
Yeah.
Good question.
One is related to the cooperation. Criticize us for not cooperating together. On the other end, when I'm looking on the Israeli high-tech industry, and especially the international companies, they have, I would say, something like zero activity against the government, with the university, on any national issue. And I'll give you one example. For example, 6 months ago, there was a high-tech lobby created the Ayman and myself joined it. So, the Israeli electronic organization, with a system, Mellanox came. There was no international company that actually was involved. And you said we have to work with the government. You have to realize that a lot of the problems in, let's say, the electrical engineering department, you derive directly from your needs, but you don't need to raise these needs to the government. And basically, we are just being cut with all the other disciplines, maybe in the war or something. And so, in that sense, I think that the support that we get from you is really huge.
I think, well,
I don't know about
I'll tell you.
as a government for us.
So I think international companies don't, first of all, it's the company. It's less about Israel or US or whatever. Okay, so that's, kind of one layer, and you always need to remember it, because this is not an Israeli company. Okay, and it's not about making Israel great or making India great. And by the way, I can tell you that when I came to my job, the number one thing was, it's not about this or that geo, because if you do that, then you don't become a global company. Okay, so that's one thing. But saying that, there is Intel Israel, okay, and there's a lady called Maxine Fassberg. I don't know if you met her, and I think she's doing a lot, okay, with the government and with many programs, okay, to try and push. Now, I don't know who you guys talk to in Intel, okay, and maybe this is something that we need to.
People organize a lobby are not us.
No, with Zisapel we talked specifically on this program. For
but I'm saying in the Knesset there were always 3 meetings. I've not seen even one international. And regarding vaccine, with all due respect, she's really representing the far much more than she's representing everything that you just described.
Yeah, but this is. I think.
Again, it's not only our detail. I didn't see Frisken or PI or.
As I told you, you're not going to see an international company, okay? No. I'm saying you're not going to see an international company stepping into the Knesset in and out because of the fact that this is an international company, okay? They don't, it's not about the local thing, it's about the company. Saying that, there are ways to help and push, okay? And for example, when we talked about budgets to ACC, one of the things that we did, basically, the fact that Intel stepping in to support this kind of program, and we were the first, and we said, we're going to put money, okay? And that helped, the Motorola guys, and Zohar was part of it, et cetera, to come and, go and convince their guys to bring in money. So on the Knesset side, I would watch out, okay? I think that what you're saying is the fact that Maxine is not highly aware of this area, okay? It's a very important and it's a very good point, and we can do something about it, okay? We can actually set a meeting, and I can, as a retirement guy, I can join it, and I think she's she's extremely aware of the issues, and she's extremely wants to support and help.
The second question is related to what Safi just asked. You know, I'm not the one who object students working, but we have to realize that we are fed from graduate students, and we are fed from PhD students who go to postdoc and come back as faculty. And today there is a real crisis in faculty. For example, my department has 10 openings that we cannot hire. Now, if you looked on the students that I presented in my slide, you see that all of them went to the local industry after PhD. Which means that less and less students today are just preparing themselves to be faculty. And that's something that I think that your programs, in general, again, it's not Intel, but the industry doesn't touch, because if you don't send the people for postdoc or even PhD, let's say, non-CMOS, and get them back, you'll never have faculty here. Because you cannot create by your RF engineers faculty here to do it.
Absolutely, and I think this is.
The question is how we can cooperate.
So again, I think this.
Cultivate faculties that can. For example, Ran Sofer, who we just mentioned, he did it on his own after consulting with me and other people. He never got support from everybody to do it.
No, absolutely. I think we have a big gap in this arena. We started with the ACC, and I truly think, and again, I'm not representing Intel in this case, but believe me, if you talk to Maxine, she will definitely will support that. And I think that's probably something that we can take out of this session, is to try and set a meeting, okay, with Maxine, and try to, talk about what can be done in this arena, okay? Because if there is a way or there's a need from the industry, okay, and we can support it, at the end of the day, everybody wins from it. Okay, so the academy will win, and the people in the industry will win. So I don't think, there's a will. So now there will be a way, right?
Unfortunately, like in many cases, money plays a big role in solving the problem that you mentioned. Even when you mentioned what happened in Taiwan or in China, it's part of the fact that the government just decided to invest a lot of money and make this difference. Now, we don't have much control over the Israeli politics and what they do to the Israeli academia, and I don't want to discuss about that. Maybe you can help, the Intel can help on the way that Israel discuss, but speaking about direct contribution of the companies, and I appreciate a lot what Intel contributed to Tel Aviv University, but I also mentioned at that time that it was much, much lower than what Intel gave to, let's say, a similar center at Berkeley. The same Intel gave much more money to a similar center in Berkeley.
It's not the same Intel.
Exactly.
It's the Intel in the US gave to Berkeley.
Exactly.
It's bigger in the US. They get bigger money.
So because of this money shortage, I mean, if you want to do research in, I don't know, information theory, when you need only paper and pencil, you want to do research in RFIC, where you need to bring up a lab, which will cost a lot of money, and you have to search for this money all the time. You will not, I don't know, you will have our time to publish papers and get tenure, etc. Your choice will be clear. I mean, for some kind of academic activities, you need much more money. And when you don't have it, you lean, I mean, we have talented people, so you lean to more theoretical research, which is good. I mean, we see it also in the Israeli industry later on. Those are the strengths that you mentioned. But again, the solution is money, and I think the industry should do more. And one other thing that I think the industry should do more is to have more patience. I mean, the academic life cycle is much longer than the product life cycle that we see. I mean, the time to market that you mentioned. I have a little experience in the industry, but I had more experience in the academy.
So I think on that one, setting expectations is the most critical thing to do, okay? And be very clear about it, not, nice about it, right? Which is, kind of the tendency everywhere, by the way, in the industry, in academy, and all these places. But I think when you look at resources, and everybody is short of resources, okay? When, just kind of for your kind of reference, when we decided to give the money to ACC, at that time exactly, we fired 200 people around the world, including Israel, okay? So you can imagine what it means, right? By the way, the money that we gave is one person, okay, with salary. Yeah, but it's one person with his family and all of that. So at the end of the day, when you look at it, I think this is about allocation of money. So I'll just give you a small example, okay? When you look at silicon development, right? When we're in the industry, and again, I'm not representing Intel right now, I'm talking about kind of the way you think, okay? A company, at least as big as us, can come out with a tape out every, 2-3 months, okay? Tape out like that can cost between, $1 million to $2 million, okay? There's no way that you can spend it. It's probably your, 10-year kind of budget. But on that big wafer, we got many kind of chips, okay? And we can always squeeze another few transistors for you to go and check a new idea, okay? So this is something that you just need to think differently. And when you start the communication, someone will come with this idea and say, hey, you know what? I'll go and, talk to TSMC, see if it's okay. If you can, as part of a common project, we can go and do this and that, okay? And suddenly, the money that you put on Moses and TSMC and waited a year for the thing, okay, costs zero and will get you, in 2 months, okay? One example. Another example, okay? The amount of equipment companies have in general in the industry is huge, okay? How long it takes you to buy a spectrum analyzer? Ages, right? And we have so many stacking over there, overnight doing nothing, okay? And again, just by conversation, if you come and say, look, this is what I need for that specific project that we do, okay? And then suddenly, all the money that you thought that you need to put on that can go to something else. So it's about allocation of resources, and definitely the beginning of that is conversation and discussion, okay? And I think that openness, okay, and that kind of, okay, this is what we want to do, this is what we have, etc., that basically what will change, okay? And don't expect to get $1 million from...
Thank you all for coming.
Thank you very much.